Okay, so we're going to be talking about dividing fractions. It's not super complicated, but it is new to us. So let's go ahead and get into it. So example A wants to know how many fourths are in 2. Okay, well, in order to understand that, we have to partition each of these bars into fourths. So I'm going to split it in half here, and here, here, and here, here, and here. And on the inside, I'm going to write 1/4. Okay? Sorry about that. 1/4, 1/4, 1/4. Now, there is a rule we're going to use. It's not the only rule, but it is an effective rule, okay? This is called KCF, keep, change, flip. So, first we need to understand that 2 is really always 2/1. Now, the thing we're going to keep is that first fraction, okay? We're going to keep that first fraction, and I'm going to end up rewriting it over here. So I'm going to keep that first fraction at 2/1. I'm going to change my division sign to multiplication, and I'm going to flip the second fraction so that it's not 1/4, it's actually 4/1. I multiply directly straight across. 2 times 4 is 8. 1 times 1 is 1. You can leave it like that or simply just write 8. Now, when we look at our 1 whole, we have 1, 2, 3, 4. When we look at our second whole, we have 5, 6, 7, 8. So, how many fourths are in 2 wholes or 2 whole groups? It's 8. I'm just going to lightly shade it in because as we move on, not all of our groups are going to be this even. Okay, so this, perfect. It's all shaded in. Okay. Example B wants to know when 3/4 is divided into 2 groups, how large is each group? Okay, so we're going to do the same thing here. We're going to keep this fraction. And I'll write it right here. We're going to keep the first fraction. We're going to change division to multiplication. And we're going to flip 2/1 to 1/2. Now, when we multiply directly across, we end up with 3/8. Now, that means we need to partition these fourths into eighths. And you do that by cutting each fourth in half. So now we have 1, 2, 3, 4, 5, 6, 7, 8. And I will label each one 3/8. No, 1/8, sorry. 1/8, 1/8, 1/8, 1/8, 1/8, 1/8. Now notice how on the top the whole thing is shaded, so we shaded all of the bottom. Here, only 1, 2, 3/4 is shaded. So I'm actually only going to shade my eighths to that point. Otherwise, my shades don't match, which means that I wouldn't be dividing correctly. Okay? So I have this. I'm going to shade it in a little bit. You can see the color. And now it matches where this one ends. Now, they want me to put this in 2 groups. 2 groups of 3/8, because that's what I have. So 1, 2, 3 will give me my first group or one group. One group. Here, another 1/8, 2/8, 3/8. Make up another group. So now I have two groups, which is what we wanted our 3/4 to be divided in. What does it become? 3/8 per group. 1, 2, 3/8 per one group. We're going to keep on going. When we get to the bottom of this page, now they want to know when 5/6 is divided into two groups, how large is each of those groups? So that tells me, before I even do anything here, I have to partition my top box into sixths. So I'm going to do that. And then I'll label each one as 1/6. Okay. Now, I only have 5 of those 6s. Sorry. So I'm going to shade in only 5 of those 6s. Awesome. So now I'm going to go back to solving this. I know it's really 2 over 1. I know I have to keep, change, flip when I'm dividing fractions. So I'm going to rewrite this as 5 over 6 times 1 over 2. I'm going to multiply it straight across. 5 times 1 is 5. 6 times 2 is 12. So I end up with 5/12. So that tells me that my bottom bar should be partitioned into 12ths. Well, let's make it easy on ourselves. We're going to draw the same lines we drew for our sixths. And all we're going to do is partition each of those boxes in half to create our 6 times 2, which will give us our 12 boxes. So 1, 2, 3, 4, 5, and 6. So now I have 12 boxes. In each one of these 12 boxes, I'm going to write 1/12. And I'm going to use the same color to shade. But again, I'm going to make sure that my shading matches. Right here is where my 5/6 stops. So that's where I'm going to stop down here. Now again, we already solved. Why? Okay, sorry. So, since we already solved it, we know that we should have 5/12 in each group. 1, 2, 3, 4, 5. Here's my first group. That's one group. 1, 2, 3, 4, 5. My other group, and that's what it looks like for that particular problem. Okay, so here they want to know 2 divided by 1/3. Okay. So we're going to create 2 boxes here. This can be 1 whole. This can be 1 whole. And they want to know what these 2 boxes, or what 2 is divided in if I divide it by thirds. And each of these boxes is going to be 1/3. Now, we're going to draw the 1 under the 2. And remember, we keep that fraction. So we're going to keep the 2 over 1. We're going to change our division to multiplication, and we're going to flip our 1 over 3 to 3 over 1 and multiply directly across. We should end up with 6 over 1, or just 6. Now again, this works out. 1 whole, 2 wholes. Divided by thirds is 1, 2, 3, 4, 5, 6. So we end up with 6/3. So here we can shade the whole thing just like example A. There's 1 whole. Here's a 2nd whole. And our 3/3, that represents 1 whole. Our other 3/3, that represents the other whole. If we were to get 2 and divide it by 1/3, we would end up with 6/3, which is exactly what we have here. All right, next page. Okay, so we did it, but now we're gonna kind of just talk about it in actual steps. Okay, so first thing you want to do is change each mixed number to an improper fraction. Then you rewrite the first fraction and change division to multiplication. Then you find the reciprocal of the second fraction, meaning you flip it, okay? So let's go ahead and get into it. We're gonna do number 3 right here. I'm gonna say it's 6 over 1 times 4 over 3. Now, before we cross multiply, we want to look for something called like terms. 1 and 4 don't have any like terms outside of 1, which would be pointless. But 3 and 6 share a like term of 3. 3 can go into itself once, and 3 can go into 6 twice. So now you just multiply straight across, multiply straight across. You should end up with 8 over 1, or just 8. All right, let's do the same thing for 4, 2/5. That stays the same. We're going to keep that. We're going to change our division sign to multiplication. And what should have been 3 over 1 is now going to be 1 over 3. Now here we don't have any like terms. We don't have any common factors. So we're going to multiply straight across. We should get 2/15. And that will be our answer here, 2/15. Now, when we get to this mixed number here, there's a little trick that we can do, and it's called the walk around Texas, okay? So I'm going to walk around Texas. So TX means Texas, right? But also it means that we're adding our numerator and multiplying our denominator by our whole number. So as we walk around Texas, we're going to do 4 times 2, which is 8, plus 3, which is 11. 8 plus 3, 11. And we keep our denominator. That stays the same. I'm going to keep that fraction. I'm going to change my sign from division to multiplication. Should be 5 over 1, but I'm going to flip it to 1 over 5. Multiply straight across. You should end up with 11 over 20. That is as far as we can simplify that. So that becomes our answer. Now this stuff's a little important. It says as you divide fractions. Okay? In real world situations, consider asking yourself the following questions to guide your thinking and to help.
The Tom report to dismissal. Krishan, the Tom report to dismissal. Your ride is waiting.
Asking yourself the following questions to guide your thinking and to help you understand the situation. So,
Gideon, Occhiati report to dismissal. Gideon, Occhiati report to dismissal.
golly. So you want to ask yourself what is being split up, what value represents the number of groups, and what value represents the size of the groups. And does your solution make sense in the context of the situation? So, let's think about what that looks like for our next problem. Number 6. It says Kayla works at a pizza place and the tomato sauce cans contain 14 cups of sauce. Perfect. I'm gonna need that information. Tomato sauce cans contain 14 cups of sauce. It says if each medium pizza uses 3/5 cup of tomato sauce, how many medium pizzas can Kayla make with 1 can of tomato sauce? How many pizzas can Kayla make with 1 can of tomato sauce? Okay, let's talk about what we know. We know that 1 can of tomato sauce, so 1 can of tomato sauce contains 14 cups, or is equal to 14 cups. The other thing we know is that 3/5 of a cup is needed for each medium pizza. Perfect. Each medium pizza. What do we need to know? Right here. How many medium pizzas? How many medium pizzas can Kayla make with 1 can of tomato sauce? Okay, perfect. Sauce. Awesome. Now, this is how we're setting it up, okay? Their 1 can of sauce is actually equal to 14 cups, okay? But we're only using 3/5 of that cup. So we're gonna figure out by dividing 3/5 of a cup. Okay, now, of course we can't do that. This is actually over 1. We're gonna keep that fraction, but I'll write it down here. I'll say 14 over 1 times 5 over 3. Multiply directly across. We'll do this. 14 times 5, 22, 7. Perfect. 70 over 3 is 70 divided by 3. 3 can go into 7 twice. Gives you a 6. 7 minus 6 gives you 1. Pull down your 0. 3, 9, 1, decimal, 0. And you can start to see that it begins to repeat itself over and over and over again. So in case you didn't know, when you have 0.33 continuous, this is equal to 1/3. So our solution is that Kayla can make 23 and 1/3 pizzas. Kayla can make 23 and 1/3 pizzas with 1 can of tomato sauce. And that's it. So that is dividing fractions. Hopefully this was helpful. I really, honestly, truly hope this helps. And we'll go from here. All right. See you guys later.